Good morning, good noon, good afternoon, good evening, class. Okay. In this video, I'll be discussing about, as promised in the earlier video, I'll be talking about uh, electric field calculation for or of a disk of charge. So this is, we have a disk of charge. It's another example of a continuous charge distribution. In electricity, in electronics, uh, the plain tawag dito, sheet of charge sheets of charge are always used, no? For example, flat disks, square plates for parallel plate capacitors, rectangular plates. These are usually used so that somehow the electrons will be given a more direct path, no? So they use planes of charge. So these planes of charge or sheets of charge, we call it electrodes, no? So it is practical that we will also uh, derive the equation for the electric field of a disk at a point along the axis that cuts perpendicular through the disk or the plane, no? So this is a two-dimensional charge distribution. Unlike in the first, na we have the ring and the line charge, which are still si ring is it's like a line charge that is bent into a circle, no? So this time for a disk of charge, it's like putting together. Hala! The puppy here is doing something. What time? Okay, sorry for that. So we consider the disk of charge as another mathematical disk wherein the thickness is minimal. So this is just a two-dimensional uh, charge distribution. No, it's just planar, plane or sheet. Ayan. So we consider this disk as somehow composed of several rings. So if we recall, we derive this equation here in black ink, no? The electric field of a ring on axis, and it's 1 over 4 pi epsilon sub naught z times the total charge of the ring over z squared plus r squared raised to 3 halves. So since we consider the disk of charge as composed of n segments of rings. Okay. So since that is our uh, simplified shape, then we can start with this equation, no, for every segment. So what we do now, our first step, we assign the coordinates. So I've already assigned the coordinates here. We still take XY plane as the plane of your monitor of your laptop. And then the axis that cuts perpendicular through it is the x-axis. Now, second step, after determining the coordinates now, we will divide the disk of charge into several segments of rings. So let me just copy paste the segments that I have drawn in another, and let me copy paste it somewhere here. Ayan. So, liitan natin konti. Oops. Hiri oops. Ayan. So, say for example, we've already um, hindi pala siya makita. So, mali pala ako. Okay, ayaw niya. Sige, ako na lang mag-draw. Let me pause here for a while kasi sayang ang airtime. So, pause muna ako. Okay, let's continue. There. Ay, nako. Anyway, sige. So, second step, we have already divided the disk into n segments. And we will choose one segment of this set of rings and call it as our ith ring or ith segment. So, say for example, and then once we choose the segment, we divide it further we will start na establishing the equations kasi nag-end segments na tayo dito. So, uh, let's choose this ring, for example, this one, itong ring na ito. So, let me shade it there. So, this segment now of one ring, yan, I will call this now as my ith particle. Okay. But the particle itself is of course a ring. Kasi nga, this is composed of several rings. Okay. So this ith particle also carries a part of the total charge. Now, the total charge of this disk is, we consider this as total charge. It's given in the problem, but I forgot to mention it here. The total charge is positive Q. And then the radius of the disk is big letter R. Radius of the disk. The entire disk is R. We want to determine the electric field of the disk at a certain point. Let's call this point P, where from the center of the disk going towards this point is a certain distance z. So that's the definition of z. It's a distance, a perpendicular distance between the point of evaluation and the center of our sheet here. No, or perpendicular distance. It's the same at any point, diba? I mean at the same distance p. So if I po, yon. So that's z. So therefore, the ith particle here carries a small portion of the total charge. So we say that it carries with it a little amount of charge, and that's for the ith particle, the Qi. This is still countable number of rings, no? So this is still individual particle, sub I. Okay. After that, we now sketch. We know from the previous discussion that the on-axis electric field of a ring, if it's a positive charge, it goes towards positive direction, right? So at this point, we know that this is now the electric field of the ith particle. Tama ba? Always towards the positive I. So what we are going just to do now is to sum up all these EI, particularly the EIX, IZ, I mean. So each ring has this electric field contribution. So we will add all these EI because of these other N segments of rings. So everything is just uh, summation of the Z. So we can say here in our definition that if we sum up all these components, E sub I Z, this will now be the electric field of the ring on axis. On axis electric field. And this is what we are going to do. So we will just sum up. So it's just a matter of uh, substituting for the appropriate symbol. So let's define things further. So for this ith particle natin, if we sketch it separately, goes somewhat like this. Ayaw niya talaga mag-auto shape. Forgive my drawing. Kapangit sa akong drawing, oy. Yan. This is the ith particle. My God, it's pangit. Anyway, uh, wait. I don't want it. Let me erase it and let me copy something from the PowerPoint na lang. So, I want this. Wait guys ha. Yan. So, let me just copy paste the shape. Kasi si Microsoft whiteboard, parang mahina siyang mag-auto shape. Ayan, ito na. So, this is the ith particle. Ayaw na niyang mag-small. Sige, yan na lang. Okay, fine. Yan. So, if we, sana ako? Ayan. So, ay! Ayan na naman siya. There. So, the width of this ring, ito, the width is defined as delta R. Yan yung width niya. And then the radius of the ring, we'll call it R of the ith particle, small letter R. The capital R is for the entire disk. Small letter sub I is the radius of each ring. Yung dinivide natin. Take note of that. Okay? So with that, since this is a circle, we know that the circumference of a circle is 2 pi and then the radius is R sub I. Ayan. Okay? So, kasi kailangan na, we need this later as we unroll the circle and take the area of the ring. So, klaro na yan siya dyan ngayon. So, with these definitions now of our variables, we go back to the electric field of a ring kasi we are not summing it up yet. So, we now say here that a single electric field in the Z component is 1 over 4 pi. This is for a ring. And then Z. And then instead of writing capital Q, we know that the charge carried by this small single ring is delta Qi. So we will substitute capital Q here with delta Qi because this is a single ring. And then we still have Z squared, but the R of the ring is R sub I. So that's the crucial part of the substitution. Otherwise, if we happen to have a mistake in the substitution here, we will never arrive at the correct answer. So now that we have substituted the correct symbols here, the next would be to express delta Q. So we say here, express delta, I'm sorry, this should be delta Q sub I for the single ring. Express delta Qi in terms of coordinates. So in other words, we will put in, I'm sorry, we will put a substitute for delta Q in terms of surface charge and the coordinates like area. So in terms of coordinates, kasi we will be integrating later, di ba? Terms of coordinates. So what do we mean by this? We know that the surface charge density of a certain area is given by Greek letter eta or eta. And this is charge per area. So if you just, this is total charge per total area. So if we just use the charge of the single ring, Q sub I, cross multiply, since the charge is uniform, I forgot to mention, this is uniform charge distribution. Uniform charge distribution. If it says in the problem that it has uniform charge distribution, then the surface charge density is constant in any part of the distribution. So we say that eta is constant. It doesn't change. So we still have eta here times the area. Since this is a small charge, then the area of this single ring, we will call it also as a little of the total area and then ith particle. So this becomes delta A sub I. Now, you learned probably in your calculus how to unroll a circle so that it becomes a two-dimensional surface. So, unrolling the circle or the ring will give us a rectangular strip where the length, okay, so if this is our strip now, let's use the black. Itong ring dito, i-unroll natin, then we will arrive at more or less, let's just say this long. So, where the length is of course the circumference, that's just 2 pi r sub I, the length of your rectangular strip. And then the width is your, correct, the delta R as defined earlier here. So the area The area of this small strip is, of course, just a portion of the entire area, sub I. So the length is 2 pi r sub I, and then the width is delta r. So we'll substitute it here for A, such that delta q sub I will be substituted with eta, and then 2 pi r sub I delta r. We have to be very careful with the symbols, no? Otherwise, magkamali tayo. So we now have a substitute. Si delta q sub I ngayon is already expressed in terms of coordinates. When I speak of coordinates, ito yon, the r and delta r. R sub I and delta r. So going back here, this now will become 1 over 4 pi epsilon sub naught z, and then you have eta 2 pi r sub I delta r all over z squared r sub I squared 3/2. This is for a single ring. So we need to get the total of all these single electric field. So we take out all the constants on the left side. And then if we further simplify, your 2 pi here, it gets cancelled with the 4 pi here. Ito, 2 na lang ito. So we have z is constant, eta is constant. So we put it out of our summation. We put it together with the constant here. So this becomes z eta over 2 epsilon. And then what is left here would be the quantities that we will sum up. So we are left with r sub I delta r over z squared r sub I squared raised to 3/2. And then the limit would be from I equals the first string, 1, until how many n segments that we have. Okay? Now, the next thing now is, if we let the segments to have a very, very short, narrow strip, then we say, therefore, that we divide the segments into uh, countless divisions, so that we say that for, or if we let so let the number of segments be approaching infinity, so many that it's not practical to do the individual summation. This is now a clue that we need to transform into integral calculus. So what's the implication? If the n now approaches infinity, then the individual, what used to be a discrete r will become a continuous variable. R na lang siya. Okay? And then what else? See, that's R. And then the strip, that is delta R, the width of the ring, will now become infinitesimally small such that it becomes dr. So we're now transforming symbols, ha? And then our limits would be, so for the limits, we have from, so if this is our disk, ay, kapangit. If this is our disk now, you will be integrating from the center where r sub I, or r is 0, no longer r sub I, from r equals 0 until r equals big R. No, that's the entire, so the integration would be from the center. We add all of the rings here until small r equals R. So our limit now from I equals, hey! Oh my God. Individual I, this becomes now R equals 0. And then Cn, this will be until R. And then finally, the summation will become an integral sign. So putting this together now, we now transform into integral calculus. So we say, therefore, that the summation, let's just say pa rin summation. So the summation, the unknown natin, the total of all the EIZ is equal to, nothing changes with the constant kasi nga they're constant. So we have 2 epsilon pi. And then the summation will become an integral sign. R sub I will be R. Delta R is dr. Ayan. So, klaro na na integrating variables na talaga ito. Ang sa ilalim, of course, they do not change. A square, except for the R sub I. So, the R sub I here will just become R as a continuous variable, 3 halves. And then our lower limit would be from R equals 0 to small r equals capital R. Ayan. So now that you have transformed from summation to integration, if you look at the function here, the integration part will become straightforward if we will do some substitutions. So we will employ uh, integration by substitution. So integration by substitution. What's another term for this method, if you recall? So integration by substitution, it's also known as the U substitution, because a certain function, papalitan mo ng function U. So it's also called U substitution. And then it's also called as the reverse chain rule. Ayan. They all mean the same thing. The reverse chain rule. Ayan. So, the critical part in U substitution is defining your functions correctly. So, we will define functions here. So, we will let this function sa baba as our U. So, we will let our U function to be equal to Z squared plus R squared, such that if you get du, no, in terms of R, this will just be 2R dr. Eh, our intention is to have a substitute for R dr dito sa taas. Kasi sa baba, magiging U na ito. So if we will transpose 2 to the other side of the equation, it will just become 1/2 du. And this is now R dr. So this is now what we will substitute for R dr here, so that the equation now will become, so this is now Z eta over 2. I hope you're still following, no? And then, so we have R dr will be substituted with 1/2 du. Okay. And then Z squared plus R squared, we define it as U. So we have U raised to 3 halves. So this is now a more straightforward integration. Okay? Now, if you change the variables in your integration, you also have to change the limits. So changing the limit now, changing the limits, the lower and the upper, we will base it on this definition that we have here, of course. So the limit now, the lower limit, we set it earlier as r is equal to 0. So from our u, it becomes z squared plus r squared. But for r equals 0, this is out of the equation. So the lower limit now becomes z squared. So, lagay natin dito, instead of 0, this becomes z squared. Now, let's go to the upper limit. In the upper limit, we mentioned that that is where r is equal to capital R. So, going back to our u function, this becomes z squared plus capital R squared. So, this is now our upper limit. That's why you have your z squared plus r capital R squared here. Okay? And then the integration now will just be straightforward. Okay, so this becomes, we can factor out 1/2 out of the integral because it's a constant. So let's remove this from here. and then it becomes 1/2 dito sa kabila. So this will become Z eta over 4 epsilon sub naught. And then the integral of this will just be -2 over u raised to 1/2. Ayan. Review nyo na lang ha, paano ito kinuha. Ayan. And then, of course, the lower limit is z squared. And then upper limit is z squared plus r squared. So we now just substitute substitute it by z squared plus r squared minus the lower limit. So further simplifying, we have here, pwede natin tong gawing 1, and then ito magiging 2. So balik ulit siya sa 2, ang gulo niya. Okay. So you have z eta 2 epsilon sub naught. And then if we now substitute u for the upper limit, it becomes -1, and then ang u sa baba is the upper limit, of course. So we have z squared plus r squared, but you have raised to 1/2 here for our u. Minus another -1 here, because it's really -1 man, di ba? Over the lower limit is z squared and then raised to 1/2. Okay, ayan. So we just simplify this. This will become z eta 2 epsilon sub naught. And then this becomes -1. Pwede nating i-rewrite ito as square root of z squared plus r squared. I think we're almost done na. And then minus minus becomes plus 1 over, ito siya magiging z na lang. So if we look at the answer, we just need to tawag nito, simplify this further, no? Let's go back to the answer first para so that we know how to rearrange. So this is our answer. Let's copy this and then put it here in our solution. There. So this is the answer, no? So we want, so walang z dito sa labas. So we need to distribute it. And then, i-rearrange lang natin siya. So rearrange natin. So distributing z, our intention is of course to arrive at this form. So we will distribute z to both terms so that this becomes eta over 2 epsilon sub naught. And then we have -z over square root of z squared plus r squared plus z over z, which is of course, it's just equal to 1. So dito sa final answer, inuna lang si 1 na sinulat. So we can also do that. We just interchange the 2. So this becomes eta, ayan, epsilon, and then we write number 1 first, and then ito na siya. Minus, you have the z over square root. Yay! We got it! This is now the summation of all the EIZ. And then if we put this now as a vector, we of course know that it is going towards positive z as a vector now with the direction. And this is of course equivalent to the electric field of the disk. Ayan, on axis. This is only true for on axis, ha? If it's not on axis, never dare use this equation. Okay, so this is, oops. Let's make it bigger. Ayan. And then, ano naman ito siya, uy? Ay, ayaw na naman niya. Paano ba ito? Ayun. So, therefore, okay, hey, we got it. Now, we're almost done. We need to test some limits here, no? So, let's ano muna, let's visualize. Let's evaluate the physical meaning of this. So we are saying here that for our disk, Ano yung magandang drawing natin sa disk natin? Ito na lang. Okay. So for the disk that we are saying here, picture natin ano ibig sabihin ng na-solve natin ha. Okay. So if you have pala a disk of charge, okay, a disk of charge, okay? So it's a plane, it's a sheet of charge that is just shaped into a circle, okay? We know that for the on-axis electric field, excuse me, at a certain distance z along the axis of the disk, you have this electric field. So kung dito sa harap at a certain you have the ring of charge somewhere here. This is now the electric field at this point. So if this were a positive charge, no? Kung negative, papasok. So a certain distance here, it will also be like that. Electric field din yan. Now, let's set some limits here. What happens if we have what we call an infinite plane of charge or infinite sheet of charge? Infinite sheet of charge. Pag sinabi mong infinite sheet of charge, we are saying that the Z is much less, ay, ano ba yan? The Z distance, ito, is much less than the distance from the center going towards the edges. So that would be, let's say, R. No? So from the center going towards the edge. But actually, this is true for any shape. No? Pero in this case, R na lang muna. So if Z is very much less compared to R, then this equation here will apply. No? So we call this as ayan. But in reality, there is no such thing as infinite sheet of charge. Okay? But there is a finite uh, sheets of charge, like what I mentioned earlier, no? The concept of electrodes. So, see, electrodes, usually you have disk of finite shape, of course. Naghang na naman siya. Ayan. You have disks. Ayan. So, mga disk. Ayan. You have, for capacitors, you have square plates or rectangular plates. Okay? Yan. Tapos, lagyan mo yan siya ng charge and so on. So, for this, if we take, for these cases where the Z, the calculation is near the plate or parang masyadong malaki yung charge kumpara sa distance ng pinag-solvan mo, this will already be a good approximation. So, we can say therefore that this is not just for an infinite sheet of charge, but this is actually a good approximation already for a finite plane of charge or sheet of charge. So long as, and a plane of charge. So long as this condition is true. Kasi uh, if you evaluate at a very far distance where Z is much greater, then the disk will again behave as if it's just a point charge, no? Kung i-simplify mo siya. So, big sabihin, let me look at my códigos for the case that I want to discuss. Ayan. So, if Z therefore is very much less than R, etong equation natin dito will become, itong expression I mean, so if the R here is so huge compared to the Z here, then this will become, the quotient here will become a very small number such that we can just take it as, ayokong mag-erase ko na. So, okay na tayo dito, no? This is already for a finite charge, but we can also extend the case where Z is very much less than R. So, in that case, aguhin ko na lang muna. So, sulat ako na bago. So, the electric field of any plane, regardless of the shape, no, is equivalent to, so, with this case, itong expression will become 0. So, ang matitira na lang would be the eta over the 2 epsilon sub naught. And this one now, everything is constant. So the only thing that matters here now, the only thing that the factor that affects the strength of the electric field of the sheet of charge is kung gaano kalaki yung charge distribution na charge density na eta. So, oops. So meaning, ano ba yan? So meaning class, for a finite plane of charge, sorry, ito pala siya dito. So for a finite plane of charge, this will still be true, but we will evaluate it as this one. Kasi pwede lang itong applicable sa finite charge kung ang Z nga is masyadong maliit kumpara sa actual size ng sheet of charge. So, pag in-apply na natin to with this limitation, ito na ngayon ang magiging equation ng electric field of any finite plane of charge regardless of the shape. And if you notice, it no longer depends on how far you are evaluating from the plane. Kasi wala namang Z sa formula. It will only depend on the eta. So the higher the charge the sheet has, it will have a greater eta if you keep the area constant. So you increase the electric field. If you decrease the area, okay, at the same time increase the charge, then that will also increase the charge density here and thereby increasing the strength of the electric field strength. Okay? So, if we further take note of this, any sheet pala, any plane, the electric field is constant. So, you would say, why is it like that? Bakit hindi na nagde-depend ngayon yung strength ng field, ng electric field sa distance na alam naman natin pag lumayo, talagang hihina. But for this plane charge na masyadong malaki kumpara sa Z, parang it will now be difficult to determine which distance is close, which distance is far. So as far as this is concerned, it's as if any point in space surrounding the charge is close to the charge. So it's something like that. So if we have, for example, a sheet, a plane, that is positively charged, ito for example, kasi regardless nga of the shape, di ba? So if this has positive eta, Q over area, ayan, this now will tell us that the electric field at any distance from it, so we are drawing here same length of electric field. So pag same length tapos equal distances from one another, then that is referring to a uniform or constant electric field. So dito naman sa kabila, ganyan din. Kahit anong distance, no? Ayan siya. So if it's a negatively charged particle, so let's say for negatively charged sheet, let's say another sheet of charge here tapos negative, you know that the electric field, of course, is into. So, mag-draw ka pa rin ng equal distances na field vector lines para malaman ng lahat na uniform electric field. So, in other words, if you see a picture of field lines that are equidistant from each other, then that is an example of a constant electric field. And that is only true for sheets or plane of charge, a sheet of charge. So finally, I'm ending my input here by introducing the parallel plate capacitor. That's our next topic after electric flux. So when we discuss about parallel plate capacitor later, parallel plate capacitor. So from the phrase itself, parallel plate, you have two plates or two sheets of charge that are facing each other, parallel to each other. So let's say you have this sheet here that is positively charged. Tapos meron ding another equal area. Yan. So this will be negatively charged. We will learn later paano mangyayari ito. Kasi si capacitor, we will learn that it's a very important electronic device which is able to store electric energy. No? It's crucial in integrated chips. In any electronic circuit, you'll have your capacitor. So in this case, si capacitor ngayon, the area of one sheet, of the positive sheet, is also set as equal to the area of the other. And then meron siyang certain separation. Ito, hindi pwedeng magkadikit yung dalawang conductors. These are of course conductors, no? Yung dalawang sheets natin, separated by distance d. So if this is positive charge, pag capacitor, the magnitude of the positive charge is equal to the magnitude of the negative charge because of conservation of electric charges. So negatively charged ito. Ayan. So if we draw now the electric field lines here, so it's from plus going to minus. So because of sheet 1, meron ka ngayong electric field away from the positive sheet. And then dito sa kabila, meron ka ding positive, of course. Parehong field yan, di ba? Doon sa kabila din, positive. I'm using blue for the electric field lines of the positive charge. I will be using red for the electric field of the negative. So for negative, papasok doon. Ayan. Since pareho sila ng A, pareho ng Q, edi the eta of the positive is also equal to the eta of the negative charge. Meaning, the field strength at any distance from the positive plate is also equal to the field strength, no? Yung magnitude nila ng negative. Ayan, kaya equal lengths ito sila dapat. So, doon sa kabila, merong papasok dito sa negative. Ayan. And then dito sa gitna, they will have the same direction. So what happens now if we draw this showing the side view, viewed from the side, if this is the side of the positive plate and this is the side of the negative plate, then there will be charge electric field because of the plus, away from plus towards the minus. Ayan. Okay, dito, this is also away. Ayan. Mas madali pala kung nag-viewed from the side na ako. And then for the green, it's going there. So, if you notice, what happens here? Sa electric field total, sa labas ng dalawang sheets. Ito, sa labas. So, this is where the electric field, of course, the total electric field here is 0 kasi they cancel out. The same here. There is no electric field outside the capacitor, the parallel capacitor. But what happens is there is an increased electric field dito sa gitna. So, here, the E total here is high. So, this is the reason why for any charge capacitor, it is able to store electric charge within the electric field na naka-sandwich sa dalawang sheet. So, store electric charges within the electric field between the plates. So, this is how capacitors store electric energy. It's because there's a strong electric field between the plates. If planes of charge do not behave this way, then there would be no capacitor kung hindi ganito ang behavior ng material na ito. Okay? So we will learn more of this when we go to capacitor. What I'm just showing you here is that yung na-derive natin na equation for the field of charge magnitude is said to be constant, 2 epsilon sub 0. Ayan. So, kahit saang point dyan sa palibot ng capacitor mo, ang field strength pareho. Okay? 0 sa magkabilang dulo, malakas dito sa gitna. Okay? I think I have to stop here. This has been a long video, like what I always say in the previous video for this lecture series. Okay? So, study more and then I think that would be the last. Meron pang isang short video on sphere, pero masyadong maano na yun, maikli, no? So, essentially, we are done with the discussion of electric field. So, in the next lesson, we will be talking about electric flux and Gauss's law. So that after that, siguro 1 week lang yun, maikli lang naman ang electric flux at saka Gauss law, we will proceed na to capacitance. Okay? So, until then,